So I think that we can start our workshop. So first and foremost, thank you for joining the online workshop about the manufacturing as a service with the title Powering Europe's Next Industry. Please note that this is a joint online workshop in terms of the Twin Green and Digital Transition 2024 call. We are organizing this online workshop together with Medusa, Laser4MaaS, Read, UniMaas and MassAI project. I'm Eleni Provopoulou, the Dissemination and Communication Manager of the READ project on behalf of Net Company, and today I will be the facilitator of the meeting. Before we start, I'd like to inform you that we are having the Q&A feature active, so in case you are having any questions, feel free to add them on the Q&A session, or you can add them on the chat as well. Just a couple of words about the 5 project and the expected outcomes of our cluster. The expected outcomes are mainly 3. First of all, the easy access to flexible and decentralized manufacturing and remanufacturing capacities. Secondly, the availability of automation, emerging and digital technologies for the servitization of manufacturing assets, and last but not least, the improved value chain integration through the availability of technologies and models for securely exchange and leveraging life cycle data. So we will start now with the presentation of the 5 project. We are starting with Medusa project, and we are happy to have here with us Matteo Dauria and Regis Hameling. Mr. Dauria is a modeling and simulation engineer specializing in low-code platform development and AI-driven solution. He's representing Spindox, and together with Mr. Dauria is Regis Hameling, the CTO from Blumorpho, and he's running the exploitation activities of Medusa project. So let's start. The floor is yours. Feel free to share your screen and start your presentation. Thank you.
Hi all, my name is Matteo Dauria. I'm from Spindox, and today, together with Regis, I will present the Medusa project. So this is a summary of the presentation. So first of all, we will present the approach and the architecture of Medusa. And after that, we will start a little review of status of manufacturing as a service, and this will lead to our use case scenario and our business model. So start with Medusa. So the Medusa project aims to revolutionize manufacturing by enabling seamless connectivity among existing marketplace and technology by supporting the manufacturing as a service paradigms. By integrating existing marketplace, the Medusa framework will foster collaboration and democratize access to manufacturing service, allowing companies to share resources and capability in a more efficient way. Medusa will develop a comprehensive and versatile framework designed to enhance cross-company data exchange through a trusted, secure, and traceable communication protocol and pattern. This approach significantly improves production energy, facilitate asset servitization, and helps reduce cost and environmental impact through AI-based services, while also fostering collaboration through the intelligent sharing of resources and expertise. At a high level, the Medusa framework can be seen as composed of 3 main domains. The ET domains, which support users through AI and analytics. dashboards. The OT domain, which enable the use of lab data coming from suppliers and shop floor assets within the AI and the analytics services. And the marketplace domain which allow Medusa to reach and orchestrate a large number of suppliers coming from different manufacturing domains. The Medusa project relies on 5 technological pillars. The first is the manufacturing as a service decision support platform, which integrates AI, historical, and real-time data, and visualization tool through low-code web interface to support outsourcing and production planning in a MassAI ecosystem. The second pillar is the automation engineering platform for manufacturing assets based on the real-time IX 16499 and the edge to cloud computing. This platform enables the virtualization of machine and industrial assets, capturing and preprocessing real-time data that feed Medusa services such as AI optimization, predictive insight, and production monitoring. The third pillar is the multi-ontology methodology, which leverages semantic web technology and multi-ontology knowledge graph in order to model production assets, security, and manufacturing context. These enable semantic interoperability and richer information sharing across the Medusa components and third-party platforms. The fourth pillar focuses on secure, decentralized, and traceable data exchange, enable privacy-preserving communication through technology such as EPFS, blockchain, and scalable NoSQL storage, ensuring data integrity, transparency, and trust. Finally, Medusa includes a set of AI-driven tools aimed to improving sustainability and efficiency, such as provider matching, digital twin-based production estimation, energy-aware planning, and sustainability impact traceability. To realize Medusa, we rely on a layered architecture. So we identified several horizontal layers spanning from the user interface down to resource layer, each with a specific scope. And in addition, we defined a cross-cutting layers that interacts the horizontal ones at different points, addressing transversal concepts such as security, interoperability, and data management. Starting from this architecture and following a clear separation of concern approach, we identify the main Medusa component and determine for each whether it should run in cloud, on edge, or in a hybrid configuration and defining protocols. To conclude, after this overview of the Medusa framework, I will now hand over to Regis, who will provide a broader perspective of the manufacturing as a service landscape and introduce the business model that Medusa will adopt. Bye. Thank you.
Thank you, Matteo. I'm now taking over the presentation and sharing my screen. To the presentation mode. Right. So the big difference between manufacturing as a service and what we have today we are more on the manufacturing on demand scheme. And this is something which has been evolving since about the last 10 to 15 years. The big difference between manufacturing on demand and manufacturing as a service is that on one hand, you trade the goods and you maintain the supplier to buyer relationship, while in manufacturing as a service, there's a disruption of this relationship, because now you are trading resources. You are trading machine time and not really the goods. So it disrupts the standard practice of the factories. So today, manufacturing on demand, it works with a black box business model. The customer is connected to a marketplace, and the marketplace manages the supplier. You just upload your CAD file, you get the RFQ process is fully automated, so you got the price and the delivery time, but you don't know who is the supplier. And so basically it builds upon the standard outsourcing practice, but the only difference is that you have to accept not having the full traceability of your suppliers. So today, what is the status? It's mostly deployed in mechanical manufacturing and for CNC machining, 3D printing. You have on the bottom right some examples of with exometry for mechanical marketplace, where you have about 10,000 suppliers which are already listed. And on the right, it's another example, but this time for electronic manufacturing, electronic system manufacturing. So we have identified 130 marketplaces like that in the world. The majority is located in the US, and they operate with 4 different business models. The main business model is the pure marketplace. You are just a matchmaker between a buyer and a supplier. There's also a hybrid platform now, which adds on top of that some services like quality insurance, logistics, and partner management. And you can have also some fully integrated digital factories. It means that the owner of the marketplace has also some production capacity. So it's just kind of a marketplace for your sales, for your subcontracting sales. And the last one is more the embedded engineering software, which can be integrated from design to production. Here it's more licensing business model, the usual licensing business model. It's less a marketplace aspect. So what is manufacturing as a service? In fact, it's fabless. The customer is fabless. The idea that fabless is inspired from the semiconductor industry. You don't own a fab, you don't own manufacturing capacity. So you connect to Medusa to have access to all the possibilities offered by your suppliers. And you could schedule your whole production moving from one factory to another. That's the long-term vision of manufacturing as a service. In our project, we have 2 marketplaces participating, ClassGo, which will supply the mechanical marketplace, and BProduce, which is supplying the electronics marketplace. And the 2 are connected through the Medusa framework. So what are the business models that we have explored? The first one is manufacturing as a service for clusters. Clusters is very interesting because it's an homogeneous set of factories. They can be locally connected. And we took one example of the European Digital Innovation Hubs. If DRH is hosting a marketplace, they can support their client with the AI adoption. They can improve the ecosystem resilience, have a green impact, and also have a business model for themselves because they can generate some income for the DIH. So we did some interviews in this whole ecosystem, and we have identified a number of European Digital Innovation Hub. But the one which is the most interesting for us is Factory Exchange, located in Ireland, which is sharing this vision of marketplace, really a marketplace where they put together some suppliers and customers. So the idea would be to find multiple, more of these digital innovation hubs, owning their own marketplace and spreading this manufacturing as a service at the European level with this long-term vision of a meta marketplace and connecting all these ecosystems together. But this is the big ambition, the big vision. At a lower level, you need to have factories which are homogeneous, working more or less in the same ecosystem so that they can understand their specifications. And we have identified, for example, one cluster in the food packaging where you could imagine that all these companies together are connected through their own cluster. Foodpack Lab is an example of a meta cluster, where Medusa could be a meta marketplace.
So first and
but you
foremost,
can also work
thank
at
you
a smaller
for
level. You could
joining
imagine
the
that
online
you can work
workshop
in a
about
group.
the
And here, this is an
manufacturing
example
as
of
a
one of
service
our
with the title Powering
members, our
Europe's
consortium
Next
members,
Industry.
Repack, which is at the
Please
bottom
note
of the
that
slide,
this
is
is
member
joint
of
online workshop
a group,
in terms of
the ProMac group,
Twin Green and
which
Digital
which has
Transition
acquired all these
2024
companies together, which
call.
are
We are
packaging companies
organizing
for food.
this
you can see some
online
subclusters
workshop
in those
together with
organizations because
Medusa,
they have
Lasers4MaaS, read UniMaas and
the
MassAI
fragmentation
project.
of the machine packaging for food
the
and
dissemination and
beverage
communication manager of the
is
REIT
represented
project on
here.
behalf
So
of Net
technically,
Company.
REPAC
And
could share some resource with
today I
all
will be
the
the
other
facilitator
companies
of
which
the
are
meeting.
into its vertical.
Before we
And
start,
Medusa
I'd
could
like to
work as a
inform you
meta
that
marketplace
we are
within
having the
this kind
Q&A
of group of
feature
factories.
active, so in
This
case
is
you are
what we call
having
the
any
low-hanging
questions,
fruit.
feel
These
free
will
to
be
add
the
them on the
first, the early
Q&A
adopters
session,
of
or you can add
manufacturing
them
as
on
a
the chat
service
as well.
to optimize their resources.
Just a couple of
So
words about
the Medusa
the
project will
5
finish
project and the
in
expected outcomes
2027,
of our
and
cluster.
starting in 28,
The
we will
expected
start the
outcomes
industrialization
are
phase
mainly
when the
3.
market launch
First of all,
is
the
seen
easy
for
access to
2030,
flexible
and then
and
the scale-up phase will follow.
decentralized manufacturing.
Thank you very
and
much for your
remanufacturing
attention. That was
capacities.
our
Secondly,
presentation for Medusa
the
today.
availability
Thank
of
you very much.
automation, emerging and digital
Thank
technologies
you very much for
the
your presentation.
standardization of manufacturing
I don't
assets,
see
and last but not
on the
least,
chat or on the
improved
Q&A
value
section
chain
any
integration through
question,
the
but
availability of
I have a
technologies
question
and models
my side.
for
I suppose that
securely
you
exchange and leveraging life
found
cycle
some
data.
issues relating
So
with
we will
security and
start
the traceability
now with
in terms of
the
the
presentation
cross-company
of
collaboration.
the 5 project.
I don't
We
know
are
if
starting
you
with
managed
Medusa
to
project, and we are
to
happy
highlight these
to have here with
challenges,
us
let's say.
Matteo Dauria and
if you
Regis
find,
Hamelink.
I don't know
Mr.
if you find a
Dauria is a
solution in
modeling
order
and
to address these
simulation
challenges.
engineer specializing in
Yeah,
low-code
the
platform
sharing
development
data.
and
Matteo, do you
AI-driven
want to answer
solution.
that?
He's representing
You can
Spin
start, and
Dogs,
after I can
and
complete.
Yeah,
together
I
with
was
Mr.
just saying
Dauria
that
is
sharing
Regis
data is
Hamelink,
sometimes
the CTO
sensitive,
from
and
Blumorpho, and
here the
he's
idea
running
is
the
to
exploitation
work to share
activities of
data through the digital product
Medusa
passport,
project.
which
So
is one way
let's start.
to
The floor is
easily
yours.
share this information. But Matteo, you can maybe
Feel free
add
to share your
some
screen and
more
start your
technical insights
presentation.
here.
Thank you.
So yes, we will use the
Hello,
DPP in order to
my
share
name is
data
Dauria.
after
I'm
the
from
completion
Spin
of
Dogs.
the product.
And
But
today, together with
from the rental
Regis, I
side
will
data
present
that need to
the
be
Medusa
shared
project.
between companies in order to allow the
So this
manufacturing
is
of a
a
goods.
summary
So
of the presentation.
we are
So
identifying
we will
several
present
technology,
the approach and the architecture of
starting from the
Medusa.
blockchain,
And after that, we
going
will
through the
start
analyzation of data
status
and
of
filtering of
manufacturing as a
data.
service.
So
And this
we
will
are
lead
trying to
our use
define
case scenario and
a
our
system
business
that
model.
allow us to realize this
So
principle
start
and
with Medusa.
privacy
So
preserving
the
data
Medusa
sharing. So we are
projects
working on this.
aims
We have
to
already
revolutionize
identified
manufacturing
some
by
technology that
enabling
could
seamless
help us, but we are
connectivity
now putting it
among
together
existing marketplace
to realize a
and
strong
technology
framework that
by
could allow
supporting
us
the
to adopt this.
manufacturing as a service paradigms.
Perfect.
By integrating
Thank you very
existing
much.
marketplace, the
So
Medusa
now it's
framework
time
will
to move
foster
to the
collaboration
Lasers4MaaS
and democratize
project.
access to
We have
manufacturing service,
today here with us
allowing
Professor
companies to
Pasquale
share
Fraziosa,
resources and
who is
capability
head of
in a
laser
more
beam
efficient way.
welding group of the
Medusa will
University
develop a
of
comprehensive
Warwick.
and versatile
So,
framework designed
Professor,
to
the
enhance
floor is yours.
cross-company data exchange
Yes, so
through
thanks, Eleni.
a
Thanks for the
trusted, secure,
introduction.
and
Good morning,
traceable
everyone.
communication protocol
And
and
I'm
factor.
going to start sharing the
This
screen.
approach
Can you see that?
significantly improves
Yes.
production energy,
Yes, okay. Yeah, thanks again.
facilitate asset
But it's not on the
certification, and
presentation.
helps
Now it's
reduce
on
cost
presentation
and
mode.
Okay,
Perfect.
environmental
presentation mode. Okay,
impact
perfect.
through AI-based
So yeah,
services,
so I
while
am
also
Pasquale
fostering
Fraziosa.
collaboration
I am
through
from the
the
WMG, Warwick
intelligent
University
sharing of
in UK.
resources and
And
expertise.
today I will be,
At a
I'm the
high
project
level,
coordinator for
the Medusa framework
Laser4MaaS.
can
So
be
today I
seen
will be
as
representing
composed
the
of three main
Laser4MaaS
domains. The ET domains,
in
which
this
support
workshop. So it
users
looks like we like
through
revolutions.
AI and
So we have
analytics
revolutions in our
dashboards.
project
The OT
title,
domain,
and also you
which
can see
enable
we
the
have
use of that
revolution
data
within
coming
the
from
sister
suppliers and shop
project
floor assets
cluster hub as well.
within the
So
AI and
since
the
we like
analytics services.
revolutions and
And the
hopefully
marketplace
the
domain, which allow
revolutions
Medusa to
take
reach
us
and
to
orchestrate a large
improvements.
number of
So let
supplies
me
coming
try
from
to
different
navigate
manufacturing domains.
through some of the industrial revolutions,
The
which
Medusa
most probably most of
project
you are already
relies
familiar
on
with.
5
But
technological
let's see
pillars.
where we
The
go with
first is
that.
the manufacturing as a service
So
basis
yeah,
on
so we
software
start with
platform, which
Industrial Revolution
integrates
1, that
AI,
is mostly around
historical and real-time data,
mechanization, then
and
mass production
visualization
with
tool through
like electricity.
low-code web interface
Then
to
we go to
support
automation,
outsourcing
so
and
robotics,
production
PLC,
training in
and
a
control
vast
system.
ecosystem.
And these days, yeah, we are
The
still
second
living
pillar
within
is
the
the
Industrial Revolution
automation engineering
4.0, so
platform
Industry
for
4.0.
manufacturing assets based
And this
on
revolution was enabled by pretty
the
much
real-time
digital
IX
technologies.
1499 and the edge to cloud
So all in
computing.
all,
This
if you
platform
see the
enables
trend in
the
industry,
virtualization of
we have seen
machine and
like a
industrial
shift
assets,
towards like more
capturing and
manual
preprocessing
operations,
real-time
and
data
then more adoption of
that
robotic
feed Medusa
systems,
services
so
such as
autonomous
AI
and
optimization, predictive
automated
insight,
systems.
and production
So in some extent,
monitoring.
over time, we have
The
been
third
pushing the
pillar
people, so
is
the
the
humans,
multi-ontology
away from
methodology,
the
which leverage semantic
from
web
the
technology
manufacturing
and multi-ontology knowledge
system
graph
itself.
in order to model
So the
production
question we are
assets,
asking now,
security,
right?
and
How is the next
manufacturing
revolution
context.
looking like?
These
Are we
enable
really pushing
semantic
the people completely
interoperability and
away,
richer
and then
information
the
sharing
future
across the
looks
Medusa
like something like
components
with
and
humanoids in the system,
and third-party
or is it something more
platforms.
hybrid?
The fourth
Yeah,
pillar
this is something
focuses
I've
on
taken from
secure,
Google. It looks
decentralized, and
like
traceable data
the machine
exchange,
and
enabling
the
privacy,
human
preserving communication
working symbiotically
through
together.
technology such
So is the
as
future looking more hybrid?
EPFS,
Yeah, obviously we don't
blockchain, and
know.
scalable musical
This is really up
storage,
to us to
ensuring
shape
data
the revolution the
integrity,
way how we
transparency,
believe
and
is going to be
trust.
better for the humans. We don't really know.
Finally,
Now,
Medusa
within the
includes a set
context
of
of
AI-driven tools aimed
servitization,
to
and
improving
within the context of
sustainability and
manufacturing as a
efficiency,
service,
such as
this is the
provider
question
matching,
we have been
digital
asking
calibrated
ourselves
production
since the start of this
estimation,
project. So
energy
is
aware
manufacturing as
planning,
a
and
service the next
sustainability
frontier?
in factory
Most
stability.
probably yes. And how we
To
define it.
realize
So this is our
Medusa,
definition.
we
So
rely
definition of
on
manufacturing as
layered
a service
architecture.
or
So we
servitization
identified
is to produce
several
on demand,
horizontal layers spanning
customized
from the user
products with high
interface down
quality,
to resource layer,
flexibility, and short
each with
lead
a
time.
specific
So production on
scope.
demand
And
is a
in
key element.
addition, we defined across clustering layers that
Mass
interacts the
customization, so
horizontal
customized
ones
products is
at
another key
different
element.
points,
Quality,
addressing
yeah, because in
transversal
many sectors,
concerns such
pretty
as
much all the sectors,
security,
people are looking
interoperability,
for
and
high
data
quality
management.
and low cost.
Starting
Extremely
from this
flexible,
architecture and
so it
following a
means
clear
product
sequence of
diversification.
concern approach, we
And as soon
identify
as
the
possible,
main
right?
Medusa
So I
component
want to get my
determine
product delivered to
for
me
each
ideally within the
with
next
each run in
24
cloud, on
hours,
edge,
or if
or
not
in
sooner,
an
so
hybrid
short lead time.
configuration and
So that is our
deployment
definition.
protocols.
So based on this definition,
To conclude, after this
we have been building
overview
our
of Medusa
vision for this
framework, I
project.
will
So the
now
project
hand over to
Laser4MaaS
Regis, who will provide a broader perspective of the
wants to
manufacturing
enable
as a
a
service
6-point
landscape
strategy
and introduce the business
that are
model
reconfigure,
that Medusa will
connect,
adopt.
control, predict, improve, and comply.
Thank
And
you,
I will come back to
Matteo.
that in a couple of
I'm
slides.
now
And why we want to do
taking
that?
over
Because
the
we want to enable
presentation
the
and
smart,
sharing my screen.
decentralized, and sustainable factory of the future.
To the presentation mode.
Once we achieve
Right.
those strategic objectives, the
big
impact is
difference
going to be
between,
on at least what we have
manufacturing as a
now
service
within
and
the
what we have
project
today. Today we
on
are
5
more on the
industrial
manufacturing on demand
ecosystems.
scheme.
So we have
This is something
automotive
which has been
with e-mobility
evolving
sector,
since
and
about
within
the last 10 to
automotive
15
e-mobility
years.
sector, we
The
have
big difference between
significant
manufacturing on
demand for
demand and manufacturing as a
diversification.
service is that
So
on
different
one
material,
hand you
different
trade the
products,
goods
different
and you
thicknesses,
maintain
different
the supplier
alloys,
to buyer
different
relationship,
combinations
while in
from
manufacturing
different
as a
vendors
service
as well.
there's a disruption of
Food packaging,
this
and again,
relationship,
there is
because now you are
massive
trading resources.
diversification in
You are
products
trading machine time and not really the goods.
and quality
So it
requirements.
disrupts the standard
Renewable
practice of
energy,
the
so
factories.
hydrogen and
So today
nuclear
manufacturing
fusion.
on
And
demand,
again,
it
they come
works
with the
a black box
specific
business
requirements
model.
in terms
The
of energy,
customer is
cost,
connected to
and
a marketplace,
reliability.
and the marketplace
Aerospace
manages the
and
supplier.
aerospace
You just
comes pretty
upload your
much with
CAD
quality
file,
and
you get
reliability. And
the
then
RFQ
pharma again
process
is
is
very
fully
much driven
automated,
by
so
the
you
quality
got
of the product in
the
end.
price and the delivery time,
Now,
but you
our
don't
main
know
focus
who is the
is the
supplier.
high value
And
laser
so
welding
basically it builds upon the
industry.
standard outsourcing practice,
And why
but
we
the
have been
only
addressing
difference
the
is that
laser
you have to
welding
accept not
industry
having
is
the full
pretty much driven by
traceability of
industrial
your
ecosystems
suppliers.
we have in the project.
So
So
today,
the
what
laser
is the
welding industry
status?
has been
It's
growing
mostly
quite
deployed
significantly over the last few
in
years, and
mechanical
because laser on
manufacturing
its own is a
and
flexible
for
tool
CNC machining, 3D
and
printing.
technically
You
is
have
a
on the
digital
bottom right some
enabling
examples
technology.
of
It
with
fits very well
exometry for
within the logic of
mechanical
servitization.
marketplace,
So
where
there
you
is a
have
growing
about
trend in
10,000
this
suppliers
industry.
which are already listed. And on the
So
right
at this
is another
moment, or
example,
until
but this
now,
time
the
for
focus has
electronics,
been pretty
electronic
much on developing
manufacturing,
a single
electronic system
technology,
manufacturing.
like developing laser more powerful. And as you see the
So
trend
we have
from the slide,
identified
yeah, you can see over the
130
last
marketplaces like that
like
in the
30
world.
years
The
or so,
majority is located in
the
the
trend
US,
in
and they
producing
operate
lasers with
with
more and
4
more
different business models.
output power.
The main business
so these
model
days
is
you can
the
get
pure
quite easily
marketplace. You're just a
up to 100
matchmaker
kilowatts
between
laser
a
generator,
buyer and a
which is quite
supplier.
powerful, and the trend is
There's
projected to
also
grow
a hybrid
even more.
platform
So there
now,
is no
which
real limit
adds on
at this
top of
moment on the
that some
technology itself.
services like
But
quality
in the end, it's
insurance,
not only about
logistics,
power, but
and
it's about
partner
exploring
management.
new
And
business
you
models
can
to
have
cope with the
also
new
some
market
fully
needs.
integrated
And new
digital
market needs
factories.
eventually is the
It means that
servitization
the owner of the
manufacturing.
marketplace has also
So
some
now the challenges we
production
are addressing
capacity.
to enable
So
servitization
it's
are those
just kind
4
of
challenges
a marketplace
you
for
see on the
your
slide.
sales,
So the first
for
one
your
is the need for
subcontracting sales.
reconfigurability.
And the last one is
So laser is a
more the
universal tool
embedded
and is
engineering
flexible.
software, which can
However,
be
at this moment, we have
integrated from
different laser
design to
systems for
production. Here
different
it's more
applications.
licensing business model, the
There is a
usual
cost
licensing
penalty
business model.
going with
Less
that,
a
because
marketplace
eventually the
aspect.
manufacturing
So
facility
what
should
is
and
manufacturing
must
as a service?
invest
In fact,
on
it's
more
fabless.
CapEx,
The customer
again,
is
different
fabless.
lasers
The
for
idea is
different
that
applications. So there is
fabless
a
is
clear
inspired from the semiconductor industry. You
acceptance
don't own a fab, you don't
limit
own manufacturing
because of the cost implication.
capacity. So
And because of the
you
skills
connect to
needed
Medusa to have
operate
access to all the
high-tech
possibilities offered by your
technologies.
suppliers.
The
And
next
you
challenge
could
is the connectivity.
schedule your
So
whole
in the end, we want to
production
connect the
moving
single
from
machine
one factory to another.
within the shop floor, not
That's
only within one
the
facility, but
long-term
between
vision
different
of manufacturing
facilities.
as a
So we want
service.
to cross
In our project, we
the
have two
boundary
marketplaces
between facilities, and
participating,
there are
Plus
whole
Go, which
bunch
will
of
supply the
challenges to
mechanical
be addressed, starting
marketplace,
from the
and Big Produce,
interoperability of
which is
data,
supplying
starting
the,
from the
electronics
confidentiality.
marketplace. And the
And as we
two
have seen in
are
the previous
connected through the
presentation, end
Medusa
users
framework.
are not always willing to
So
share
what are
sensitive
the
information. So we have
business
to
models
find a
that we
way
have
of
explored? The
communicating
first
those data
one
between
is
different
manufacturing as a
machines,
service for
different shop floor,
clusters.
and different
Clusters
factories.
is very
Not to
interesting
mention in
because
different
it's an homogeneous
geographical
set of
positions
factories.
as well.
They can be
So there is an
locally
element of geopolitical
connected.
implications.
And we took one
accounted.
example of the European Digital
And then the last
Innovation
challenge
Hub.
is about the controllability.
If
So
the
enabling
DIH is hosting a
servitization
marketplace,
implies
they can support
flexibility.
their client with
Flexibility
AI
implies
adoption.
some level
improve the
of control,
ecosystem
and it is where
resilience,
machine
have a
learning
green
and
impact,
AI comes
and
into the
also
picture.
have a business model
So
for
within the
themselves
project,
because
we
they
are
can
developing
generate
a
some
set of
income
technologies
for the
making the
DIH.
process more intelligent.
So we did
and
some
more,
interviews in this
controllable
whole
in such a way,
ecosystem, and we have
we can have an
identified a
easy
number of
adaptation
European Digital
of the
Innovation
system to
Hub.
meet different
But the one which is the
manufacturing and
most
end user
interesting for
requirements.
us is Factory Exchange,
So yeah,
located
just the
in
project overall, we have
Ireland,
12 partners
which
within
is
the project.
sharing
You can
this
see how
vision
they
of
are
marketplace,
distributed,
really a
and we are
marketplace where they put together some
continuously looking
suppliers
for new members of the advisory board.
customers.
So if you want
the
to know more
idea
about
would
this
be
project
to find
and you want to be
multiple,
engaged through the
more of
advisory
these
board,
digital
please
innovation
let
hubs,
us know. We are
owning their own
open
marketplace
to engage
and
with new
spreading
industries, with new partners, bringing new
this manufacturing as
requirements,
a
new
service at the European level
mindset into the
with
project.
this
So
long-term
that
vision
is
of a
something
meta
important for us.
marketplace and connecting all these ecosystems together.
Now, all in all, the
But this is
project
the big
will be
ambition, the big
basically
vision.
developing
At a lower level,
two
you need
streams.
to have
So to
factories
me,
which are
the Lasers4MaaS
working more or
is the
less
glue
in the same
between advanced
ecosystem so that they
manufacturing
can
technologies
understand
and
their
AI digital
specifications.
technologies.
And we have identified, for example,
So to enable
one cluster
servitization, we must
in the food
deploy
packaging where you could imagine
manufacturing
that all these
technologies like
companies together
modular production
are
systems,
connected through their own
IoT,
cluster.
enable devices,
Food Pack
and
Lab is an
since we are
example of a
focusing on
meta
laser
cluster,
welding
when Medusa
technologies,
could be a
dynamic
meta
beam shaping, and
marketplace.
I will come to that in a second.
But you can also
So this is
work
on the
at a
hardware
smaller
side.
level.
So
You
on the
could
left-hand side,
imagine
you
that
see all the hardware
you can
related
work in a
enabling
group.
technologies.
And
then on
here,
the
this is
right-hand
an
side,
example of
we have
one of
all the
our
software
members, our
related
consortium members,
technologies, which we
Repack,
call
which is at the
services.
bottom of this
So
slide,
those are
is
the
member
services which we are
of a
developing.
group, the
And those
ProMac
services
group,
will be
which
integrated within
which has
our
acquired all
Lasers4MaaS
these companies
platform,
together,
which
which
will be
are
either
packaging
sitting on the
companies for
cloud or
food.
eventually sitting on the
You can
local
see some
machine. Now, this really
subclusters in
depends on the
those
business case
organizations
that end
because
user
they have
wants to follow.
the fragmentation of the
So coming to the
machine
6 goals
packaging
or
for
6
food
strategic
beverage
areas.
is
We have the
represented
reconfigure.
here. So
we want our
technically,
system to be
Repack could share
reconfigurable.
some resource with all the other
we want
companies
to
which
be
are
we want
into
to
its
connect,
vertical. And
okay?
Medusa
And
could work as a
connectivity
meta
means
marketplace
pretty much
within
interoperability.
this kind
Safe
of group
and
of
secure
factories.
data
This
sharing
is what we call
between
the low-hanging
parties
fruit.
and
These
users
will
and
be the
between
first, the early
companies.
adopters
And there is a
of
control
manufacturing
element,
as a
and the
service
control
to
is pretty
optimize
much
their
enabled by
resources.
sensors, AI, and
So
digital twin.
the Medusa
Then we have a
project will
predict
finish
element. We want
in
to be predictive,
2027,
not only reactive. We want to predict
and starting
eventually
in
the quality
28,
of the
we
parts
will
we are
start the
manufacturing.
industrialization phase
Or
when the
we want
market
to
launch
like
is
down
seen
select
for
the
2030,
manufacturing
and then the
parameters, like the
scale-up
welding
phase will follow.
parameters that are required
Thank you
for
very much for your
generating the quality
attention. That was
that the end
our
user is
presentation for
specifying
Medusa
in the
today.
RFQ.
Thank you very much.
We want to improve eventually.
Thank you
So we
very
want to
much
make
for
parts
your
better and
presentation.
solve
I don't
problems
see
that are
on the chat
currently
or on the
challenging with
Q&A
the current
section
welding
any
technologies.
question, but
And then
I
in the end,
have
we
a
want to
question
comply
from my
with the
side.
policy and the
I suppose
legislation.
that you
And yes, for us, digital product passport is a
found
key
some
element.
issues relating
Because
with
in the end, not all
security
the
and the
data can be shared.
traceability
Not
in
everybody is
terms
willing
of
to share all the,
cross-company
probably all the
collaboration.
sensitive data will
I don't know
never
if
be shared,
you
but still
managed
we have to find a way of communicating
to highlight
some of
these
the parameters. And
challenges,
digital
let's
product
say.
passport,
And
it looks like the
if
right
yes,
way
I
forward.
don't
It's also
know
becoming
if you
policy
find a
for the EU.
solution in
So we are
order
also
to address
contributing
these
in
challenges.
that direction. Now, just to give the flavor of some of the
Matteo, do you want to
enabling
answer that?
technologies. So this is one.
You
So
can
this
start
is one
and
of
after I
the
can
manufacturing enabling
Yeah,
technologies. So
I
dynamic
was just
beam
saying
shaping.
that sharing data is
So for
sometimes
people in
sensitive,
the welding
and
ecosystem,
here the
dynamic beam
idea is
shaping
to
is
work
perceived
to share
as the
data
next
through the digital product passport,
like
which is one way
revolution, innovative
to
revolution.
easily
Why
share
is
this
that?
information.
Because with
But
that
Matteo, you
technology,
can
we have the
maybe
possibility
add
of controlling the beam
more technical
intensity
insights.
profile pretty much on the fly during welding
we will
within
use
tens of a
WPP in order to
microsecond.
share
And you can see,
data
I mean, an
after the
animation. This is a
completion
low
of
speed
the
animation,
product,
but it gives you the idea
from the point of view of
how the
data
beam
that
intensity
need
can
to
be
be shared
controlled. And by
between
controlling the
companies in
beam
order to
intensity,
allow the
you can
manufacturing
influence
of
your
our
weld's
goods.
quality. And if you
So
influence the weld
we are
quality, eventually you
identifying
get
several
better,
technology
performance in the end in terms of
starting from the
durability,
blockchain
in terms of structural
and going
performance,
through the
functional
anonymization
performance,
of
and so on.
data
Exactly what
and
the end
filtering
user
of
wants to
data.
get
So
in the
we
end
are
at lower
trying to
cost.
define a
Modular
system
production
that allows
systems
us
enabled by
to realize
IoT-enabled
this
devices. This
traceable
is one
and
example where
privacy
we have
preserving
cameras,
data sharing. So
sensors,
we are
optical
working on
components,
this.
vision
We have
systems,
already
illuminations,
identified
modular
some technology
welding
that could
table, all
help us,
enabled
but we are
by standard
now
communication
putting
protocol,
it
for
together
example,
to
OPA UA, or
realize
data
a
sharing
strong
through
framework
JSON file.
that could allow us to
These
do
are
this.
some of the like communication platform we are
Thank you very
using
much.
at this moment.
So
And
now
this
it's
again
time
to
to move
support
to
the
the
interoperability
Lasers4MaaS
and data transfer
project.
between different
We have
devices and different
today here
machines.
with us Professor Pasquale
Database,
Fraziosa,
when we
who
talk
is
about
head of Laser Beam
connectivity and
Welding
AI,
Group
in
of the
prediction, we are talking
University
about data
of
points. So
Warwick.
developing a
So, Professor,
common
the floor is yours.
shared database
so
is
thanks, Eleni.
strategically
Thanks for the
important for
introduction.
us, and this is what we are doing.
Good morning,
So
everyone.
we are developing a welding, what we
And,
call welding
have to
process
start sharing the
database.
screen.
So this is where the user can
Can you
log
see
in
that?
online. Then
Yes.
Yes. Okay. Yeah,
you can
thanks again.
start
But it's
assigning
not
the
on the
requirements in
now
terms
it's on
of
presentation mode.
speed, in
Perfect.
terms of
Presentation mode,
power,
okay,
in terms of lead time, in terms
so
of quality
I
requirements.
am Pasquale Fraziosa. I am from the
and then on
WMG,
that,
Warwick University in
you can
UK.
add your testing.
And today I will be,
result of testing
I'm the project
experiments.
coordinator for
And then the
Lasers4MaaS.
AI
So
module
today I will
running
be
in the
representing
background will
the
come up with
Lasers4MaaS
optimal
in this workshop.
recipe. Yeah, the optimal
So it
combination
looks
of
like we
parameters
like
which
revolutions.
eventually
So
satisfy
we have
the
revolutions in our
requirements.
project title. And
Now
also
this
you
is
can
my
see we have
probably last
revolution
couple of
within
slides.
the sister
I started saying
project
it's not only
cluster
about
hub as well.
power. Yeah, it's also
So
about the
since we like
connectivity,
the
reconfigurability,
revolutions
and
and
improve
hopefully
controlling the
the
comply.
revolutions
And this
take
was
us to
one very interesting
improvements.
example.
So let
if
me
you see
try
those two
to
welds,
navigate
so the one on the left and the one on the
through
right,
some of
you
the
might believe,
industrial
okay, those
revolutions,
two welds
which
have been
most
produced with
probably
completely
most of
different
you are
power.
already familiar with.
But I can tell you,
let's see
and
where
trust me,
we
those two
go with
welds
that.
have been made exactly with the
So
same
yeah,
power.
so we start with
So the
Industrial
difference in
Revolution 1
penetration
that
is
is
nothing to
mostly
do with the
around
power, but it's to do with
mechanization,
other
then
elements
mass production with
within the system,
like
that is, for
electricity.
example, the beam attenuation.
Then we go to
within
automation.
the plume.
So
So in
robotics,
those PLC
snapshot. and
you
control
can see
system.
the cross section.
And these days, we are still living within the industrial revolution. So there is a clear variation in the wealth penetration, and this revolution was enabled by pretty much digital because of the way how the laser beam is interacting with the plume. So what all in all, if you when we are designing in industry, that is we have seen like a shift towards enable more manual operation. We are not only working on one adoption of robotics and holistic, so autonomous and automated configuration systems. So in some extent, over time, we've been pushing the people, so the humans, away from the this again from the video animation to show even the impact on the other quality indicators like surface. So the question we're asking now might be extremely how is the next revolution of pharma industry? Are we really pushing the people completely away, and then the future looks like with something like because there is a risk of corrosion in the system, risk of corrosion, or is it something more hybrid effect? So this is something those are elements could be Google. It looks like now coming on the energy side again, the human also imply the comply element. So we want to be sustainable. So is the future looking more hybrids? Obviously we don't know. Way. So eventually this is really up to us to shape with less energy consumption. The way how this is one use case we've been developing. We don't really know. And what now within the context of that we can achieve. In this case, context of manufacturing application, we can achieve 16 millimeter single pass. We have been asking ourselves welding using only the start of this project. So is 9 kilowatt service the next frontier? But if you compare with the state of the art, so here, so this is our definition, the best and the worst case. Definition of manufacturing as a service to our case, we have a competitive benefit in customized energy products with high quality, flexibility, and short depth, so lead time over. So reduction on demand. So this is a clear indicator of the competitive mass customization, our customized product, Lasers4MaaS quality technology, because in many sectors of the art for this specific, all the sectors people are looking for high quality and low cost, in the nuclear, extremely flexible. So it means product diversification. So that was my last slide. As soon as concluding, so I want to get my product. I want also deliver to me ideally within the next. We are running a workshop 24 hours or in February, so in 3 weeks' time. Is on the 10th. So that is our definition. So based on this definition, and the workshop is all about. We have been building production as a vision for this project. So the project Lasers4MaaS. And what will be wants to enable a 6-point strategy is to come up with a more consolidated, connect, control, definition of improve and comply. And I will come back to that. We'll come up with eventually. And why we want to do that? New challenges, we want to enable together smart through decentralized panel and sustainable advisory board will shape eventually the next phase into the project. Once we achieve those strategic objectives, the impact is going to be on at least what we have now within the project. There is a 5 in the workshop is free, so it's open. So we have automotive with e-mobility sector during that week. Within more than automotive e-mobility sector, we have significant demand industries diversification. So different material, different products, different thicknesses, different alloys, different. So thanks for listening and combinations from different vendors as well. Food packaging, and again,
thank you very much, Professor. I received one question about your project. The question is, what's the role of renewable energy in Lasers4MaaS? I think that you had a slide about AI, but I don't know if you can just share 2 words about the AI contribution in Lasers4MaaS.
So so the contribution of AI is on probably a couple of levels. So one level is on the controllability side of things. Now our main focus AI is the high value laser for developing like more predictive industry control system. And why we have been addressing so what does it mean from a servitization is ending point pretty much driven by the industrial so if I am ecosystems we have in the project. So the laser welding industry has been growing quite significantly over the last few years, and because laser on its own today is a flexible tool, and I'm producing and technically I don't know mobile phone enabling technology. I'll be producing it very well within the logic of my manufacturing system. Should be able so there is a growing trend in this industry, and then should be able to control. So at this moment or until now, the focus
they are
has
defined by
been
the requirements.
pretty much on
So the
developing
AI
the single
is used
technology
in that
like
perspective.
developing lasers
So the AI
more
will be
powerful,
used
and as
for
you see the trend from the
helping
slide,
in speeding
you can
up
see
the
over
process
last
of resetting the manufacturing
like
process,
30 years or
readjusting
so,
the control
the
parameters
trend in producing
onto the
lasers
machine,
with more
and then
more
hopefully we reduce all the
output power.
trial and error
So
by
this
the
there
operator,
you can get quite
so the
easily
machine will be more
up
intelligent,
to 100
more smart,
kilowatts
and
laser
more
generator,
autonomous,
which is quite
at some
powerful.
point. So
And
that
the
is one
trend,
element
is projected
of
to
AI.
grow even
So the second
more.
element
There
of
is no
the
real
AI
limit at this moment on the
is
technology
within
itself.
the
But in the
actual
end, it's not only
multi-physical
about power,
prediction
but it's about
of the
exploring new
weld
business
quality. Now I'm talking
models to
about
cope
weld
with
quality.
the new market
So
needs. And new
multi-physical
market needs
prediction, it
eventually
means
the servitization
we are
of
running
the
multi-physical and
manufacturing.
multi-scale simulations. So
So
those
now the
simulations are
challenges we are
typically
addressing to
extremely
enable
computational
servitization
expensive.
are those four
And if you talk
challenges
again about
you
servitization,
see on
and
the
we want to
slide.
get result
So the
within a
first
few
one
hours
is
or
the need
couple
for
of days.
reconfigurability.
So it means the machine should be
So
able
laser
to
is a universal
reprogram
tool and
pretty
is
much real
flexible.
time.
However, at this
And if we
moment
have to
we have
reprogram, we
different
have to
laser
run
systems
some
for different
digital twin
applications.
simulation, right? But if the digital twin
There is a cost
extremely
penalty
computational
going with that,
expensive,
because
I can't
eventually the
get
manufacturing
the results in the
facility
right time.
should
So
and
the
must
AI again is used as a
invest
predictive
on
tool,
more capex
to generate
again different lasers for
prediction with
different
the right
applications. So
physical
there is a clear
meaning behind. So to do that,
acceptance
we are deploying
limits
physics-informed
because of the cost
machine
implication
learning or scientific
and because of the
informed
skills
machine
needed
learning
to operate
So it's not only AI
high,
in the classical
high-tech
sense, but
technologies.
we're also fitting
The
into
next
the training
challenge is the
process of
connectivity.
the AI
So
network.
in the end,
We're
we
also
want to
fitting
connect the single machine
the physical
within the shop
constraints
floor,
coming
not
from
only
the
within
physical
one
equations,
facility, but between
like,
different
differential
facilities.
equations,
So we
heat
want to
transfers,
cross the boundary between
fluid flow, and
facilities,
so on
and
so
there
on
are
and so
all
on.
bunch
So,
of
yeah, so those
challenges
are the
to
main
be
elements,
addressed, starting from the
Perfect.
interoperability of
Very
data,
much.
starting from the
So now it's time to
confidentiality.
continue with Read
And as we
project.
have seen in the
We
previous
have
presentation, end
here
users
today with
are not
us
always willing
Pedro
to share
Maria de la
sensitive
Peña
information,
Tejada.
so we have to find a way
Pedro
of
is the
communicating
project
those
and the
data
technical
between
coordinator
different machines,
of
different
Read
shop floor, and
project on
different
behalf of
factories,
YESA.
not to mention in different
Pedro, we are happy
geographical
to hear your
positions
presentation.
as well. So there is an element of geopolitical implications to be accounted. And then the last challenge is about the controllability. So enabling servitization implies flexibility. Flexibility implies some level of control, and this is where machine learning and AI comes into the picture. So within the project, we are developing a set of technologies for making the process more intelligent and more controllable in such a way. Yeah, we can have an easy adaptation of the system to meet different manufacturing and user requirements.
Perfect.
So yeah, just the project
Dimitris
overall, we have 12 partners
technical
within the
manager
project. You
of
can see how they
UniMaas
are distributed,
projects,
and we are
he's currently
continuously
postdoctoral
looking
fellow
for
in Egmont
new
Lab
members
at
of the advisory
the
board.
National Technical
So
University
if
of
you want to know
Athens.
more about this project, and
Let's
you want to
continue
be
with
engaged through the
UniMaas
advisory board, please
project, and
let
then
us know.
I
We
hope
are
that Pedro will manage
open
to join
to
the
engage
call
with
and
new
continue with Read.
industries,
So,
with new
Dimitri.
partners, bringing new
Thank you,
requirements,
Eleni.
new
Can you see my slides?
mindset into the project.
Yes,
So
present
it's something important
so
for
it's
us.
perfect.
Okay, perfect. So
Now,
I'm
all in all,
gonna
the
speak
project
briefly
will be
around 10 minutes
basically
about what we are
developing
trying to build in the
two
UniMaas
streams. So to me,
project. We are building a
Laser4MaaS
platform
is the glue
for the unified
between
modeling and
advanced
automated
manufacturing
scheduling for
technologies and
manufacturing as a
AI
service.
digital
So
technologies.
the project is
So to enable
in
servitization,
the
we
start of the
must
second
deploy
year. We have also
manufacturing
two years
technologies like modular production systems,
from
IoT,
now, and the
enabled
consortium
devices,
consists
and
of
since we are
17
focusing
partners
on laser
all around
welding
Europe,
technologies,
and
dynamic
we also
beam
have
shaping,
one
and I will come
Canadian
to that in a
partner.
second.
So we have
So this is on the hardware
identified
side. So on the left-hand side,
during
you see all the hardware-related
the first
enabling
stages
technologies.
of the project,
And then on the right-hand
some
side,
main
we have all the
challenges regarding the manufacturing as a
software-related
service.
technologies,
So we
which we
noticed
call
that there is
services.
a
So those are
paradigm
the
shift
services which we are
regarding
developing.
how
And those
manufacturing
services will
resources
be
and
integrated
processes
within
are
our
offered
Laser4MaaS
to
platform,
different
which will be
stakeholders. So
either sitting on the cloud or
we
eventually
have
sitting on the local
identified that
machine. Now,
for
this really depends on the
these
business case that
processes,
end user
and resources, they both suffer from disturbances
So
and
coming to the
disruptions,
six goals,
making
or six
difficult to build resilient
strategic
infrastructures.
areas.
And also,
We have the
there are a
reconfigure.
lot of
So we want our system
variabilities
to be
during time.
reconfigurable.
So, for example, the processes
we want
offered to
we
the
want
customer
to connect,
may change over time.
And connectivity means pretty much interoperability.
In the MaS ecosystem, we
safe
move from
and
a single
secure
company
data
manufacturing
sharing
towards a
between
network
parties
consisting of
and
different
users
stakeholders,
between
and this
companies.
comes with
And
some
there is a control
key
element,
challenges
and the control is pretty much enabled by
to
sensors, AI, and
make
digital
reality
twin.
this vision. So the first
Then
one
we have
has
a
to do with the
predict
shifting
element.
demand
We
that
want to be
propagates in the
predictive,
MaS network.
not only reactive.
The second one
we
has
want to
to do
predict
with the
eventually the
disruptions
quality
of
of the
productions
parts which we are
failing to meet the
manufacturing.
customer needs.
Or
Also,
we want to
need to address
down select the manufacturing
the
parameters,
increased,
like
or
the welding
let's
parameters
say
that are
the
required
best
for generating
utilization
the
of
quality
resources
that
in
the end
order to
user
decrease
is
costs, so
specifying in the
minimize
RFQ.
idle assets or
We
infrastructure.
want to improve eventually.
And
So we
also
want to
that
make
manufacturing
parts
processes
better
and
and
supply
solve
chains are
like
becoming
problems
increasingly
that are
complex.
currently
So the
challenging
vision for
with
the
the
UniMaas
current welding
project is
technologies. And then in the end, we
to
want to
cover
comply
several needs. So
with the
the first
policy
one
and the
has to do with
legislation.
bringing together
And yes, for
stakeholders
us,
and
digital product
SMEs
passport is a key element,
into a MaS
because in the
network
end,
through a
not all the
trustworthy,
data can be
dynamic,
shared,
and
not everybody
decentralized
is willing to
ecosystem.
share all the,
Also, there is
probably
the
all
need
the
to
sensitive data will
abstract from the
never be shared,
customers
but still we have
the
to find a way of
expertise
communicating
in order to
some of the parameters.
and
And
provide
digital product passport,
adaptive modeling
it looks
and
like
enable
the right
the overall
way forward.
servitization
It's
of
also
supply
becoming
chains.
policy for the
Also,
EU.
there is
So
a
we are
need
also
for planning and
contributing
scheduling
in
algorithms
that direction.
that build modular and
Now, just
flexible
to give
supply
the
chains
flavor
that can
of some
change
of
over
the
time and combine
enabling
various
technologies,
stakeholders.
so this is one. So this is one of
Also,
the
the
manufacturing
final
enabling
thing
technologies. So
has to
dynamic
do
beam
with
shaping.
how to enable in the
So
modeling
for
part and
people
the decision
in
making,
the welding
sustainability,
ecosystem,
resiliency,
dynamic
and
beam shaping is
circularity
perceived
aspects
as the next
in order to provide overall
revolution, innovative
resilient
revolution. Why is
infrastructure.
that?
So,
Because with that technology, we have the
manufacturing
possibility
data
of
are the
controlling the
cornerstone
beam
for
intensity
MaS.
profile
We are building,
pretty much on the fly during welding,
we are
within
also
tens of
relying
a
in
microsecond. And
manufacturing
you can
data
see
spaces.
an animation.
So we are
This is a
building
low-speed
layer
animation,
for
but it gives you
interoperable
the
and
idea
trustworthy
of
servitization
how the beam
across
intensity
different
can be controlled.
stakeholders of
And by
the MaS
controlling the beam
network to
intensity,
enable the
you can
trust,
influence
to
your
enable the
weld's
cross-company
quality.
data
And if you
exchange.
influence the weld quality, eventually you
Also,
get
the platform
better
consists
performance
of
in the end,
a
in
key
terms of
component
durability,
for the unified
in
on-demand
terms of structural
modeling of the
performance,
resources
functional
and supply
performance, and so
chains.
on. Exactly
We
what the end
also
user
rely
wants to
on
get in
intent,
the end
which
at
is
lower cost.
in the notion of
Modular
intent,
production
which
systems
comes
enabled
from
by IoT-enabled
mainly
devices. This is
from
one
network
example
optimization or
where
cloud
we have
computing,
cameras,
where
sensors, optical
customers
components,
declare
vision
in natural
systems,
language
illuminations,
their
modular
high-level
welding
requirements,
table,
and
or
then a
enabled by
translation
standard
process
communication
follows
protocol,
to
for
map these
example,
high-level
OPA
requirements
UA,
to
or
specific
data sharing through
constraints in
JSON
the modeling
file.
problems.
These are
We
some
also
of the
build flexible
like
decision-making
communication
algorithms
platform we are
to enable the
using at this
modularity,
moment,
the
and these again to
configurability
support the
of supply
interoperability
chains
and data
towards
transfer between
circularity
different
goals
devices and different
and
machines.
sustainability goals, and the overall adoption of
Database, when we
cutting-edge
talk
digital
about
technologies for cloud
connectivity
manufacturing,
and
for example,
AI,
digital
and
twins
prediction,
or
we are talking about
cloud-based
data
monitoring
points. So developing
components.
a
So we are building our
common
platform across three different
shared
suits,
database
as we call them. The
is
first one has to
strategically
do with
important
data
for us, and
management.
this is what we are
The
doing.
second
So
one
we are developing a
regards
what we call
modeling, and the
welding
third one
process database.
regards
So
decision
this is where the
making.
user
So you
can
can
log
see that
in
we have
online.
several
Then
components in order to
you can start assigning the requirements
bridge
in
the
terms
collaboration
of
between
speed,
these
in terms of
different
power, in
components
terms
and
of lead
enable
time,
an
in
overall
terms of quality
pipeline
requirement.
for the automated
And then on that,
modeling and production of
you can add
assets
your
in the 4
testing
pilots
result of testing
that
experiments,
we have in the
and then
project. So
the
first
AI
pilot
module running
has
in
to
the
do with
background
the
will come
aircraft
up with
maintenance.
optimal
The second one has to do with
recipe,
the
the
automotive
optimal
seat
combination of
manufacturing. The third one
parameters
has to
which
do with 3D
eventually
construction
satisfy
printing.
the
And finally, we
requirements.
also have a logistics and warehouse
Now
management
this is
use
my
case.
probably last couple of slides.
So
I started
for
saying it's
the
not only
data
about
management
power,
part,
it's
for the
also
data
about the
management
connectivity,
suite, the two
reconfigurability,
main
the
challenges
improved
has to
control
do
and the
with
comply.
data
And
sovereignty
this was one very
that
interesting
allows
example.
different
So if you see those two
stakeholders to
welds,
keep the
so the
control
one on the
over
left
their
and the one on the
data
right, you
and
might believe,
how
okay, those two
data
welds
are
have been
shared
produced
across
with completely
different
different power.
stakeholders. And also
But I can tell
regarding
you,
data
trust me, those
two heads have been made exactly with the same power. So the difference in penetration is nothing to do with the power, but is to do with other elements. control how data
within the system.
are
That is, for example, the beam attenuation within the plume. So in those snapshots, you can see the cross sections and then the plume coming from the laser. So there is a clear variation in the weld penetration, not because of the
for its stakeholder,
mostly because of the way how the laser beam is interacting with the plume. What I want to say that when we are designing a system that is supposed to enable servitization, we are not only working on one component, but we have to take a holistic view in the system configuration to enable that level of reconfigurability. This again some video animation to show even the impact on the other quality indicators like surface oxidation, which might be extremely detrimental for like pharma industry or food industry. Nobody in the food industry wants to see welded pipes with oxidation because there is a risk of corrosion, and the risk of corrosion, the knockdown effect. So those are elements to be considered. Now coming on the energy side, again, servitization also implies the comply element. So we want to be sustainable. We want to produce parts on demand, but in a sustainable way. So eventually, good quality with less energy consumption. This is one use case we've been developing, and what we have proved that we can achieve.
A simple example
in this case, for this specific application, we can achieve 16 millimeter single pass welding using only so now 9 kilowatt looks quite high, but if you compare with the state of the art, so and here I have included the best and the worst case, compared to our case, we have a competitive benefit in terms of energy divided by, normalized by the weld joule over millimeter. So this is a clear indicator of the competitive benefit of our Laser4MaaS technology against the state of the art for this specific
let's say that
thick section
a simple schematic of what we are trying to do is that we start from this order and intent.
So that was my last slide, but before concluding,
that acts as an interface
I want also do a bit of marketing. We are running a workshop in February, so in 3 weeks' time. It's on the 10th of February. It's in Stuttgart, in Germany, and the workshop is all about laser production as a service. A workshop on advanced manufacturing technologies. And what we'll be trying to address through this workshop is to come up with a more consolidated definition of servitization. We'll come up with eventually new needs and new challenges, and then together, through our panel discussion with the advisory board, we'll shape eventually the next phase into the project. So if you want to play role in this, like shaping the next manufacturing revolution using laser as a service, the workshop is free, so it's open. So feel free to join if you are around Stuttgart area. During that week, we are more than happy to talk to new industries and new
so regarding the modeling,
eventually new attendees.
We are trying also to incorporate
so thanks for listening, and hopefully
the disturbances in the supply chain and increase the overall resiliency.
Thank you very much, Professor. I received one question about your project. The question is, what's the role of AI in Lasers4MaaS? I think that you had a slide about AI, but I don't know if you can just share 2 words about the AI contribution in Lasers4MaaS.
So the contribution of AI is on probably a couple of levels. So one level is on the controllability side of things. So we are using AI for controlling the process. So for developing like more predictive control systems. So what does it mean from a servitization standpoint?
The knowledge graph.
So if I am a vendor offering
that we have designed for
manufacturing as a service
use case,
as
and we want
like
to transfer
my
from the left side
business model
to the right hand
today
side
I'm
of the
working
slide.
and I'm producing,
for example, a supply
I
chain
don't know, mobile phone. Tomorrow, I'll be producing something else. So it means my manufacturing system should be able to adapt within very short time, and then should be able to control
decide, for
the
example,
new
the
product
flows of the incoming demand,
the production as they are defined by the requirements. So the AI is used in that perspective. So the AI will be used for helping in speeding up the process of resetting the manufacturing process, readjusting the control parameters onto the machine, and then hopefully we reduce all the trial and error by the operator, so the machine will be more intelligent, more smart, and more autonomous at some point. So that is one element of AI. So the second element of the AI is within the actual multi-physical prediction of the weld quality. Now I'm talking about weld quality. So multi-physical prediction, it means we are running multi-physical and multi-scale simulations. So those simulations are typically extremely computationally expensive. And if you talk again about servitization, and we want to get results within a few hours or a couple of days, so it means the machine should be able to reprogram pretty much real time. And if we have to reprogram, we have to run some digital twin simulation, right? But if the digital twin is extremely computationally expensive, I can't get the results in the right time. So the AI again is used as a predictive tool, to generate the active prediction with the right physical meaning. And to do this, we are deploying physics-informed machine learning or scientific informed machine learning. So it's not only AI in the classical sense, but we're also fitting into the training process of the AI network. We're also fitting or adding the physical constraints coming from the physical equations, like differential equations, heat transfer.
I see that Pedro joined the call now. So as I mentioned earlier, Pedro is the project and technical coordinator of the READ project. And we share some information with us about the digital product passport. Pedro is the project and technical coordinator of READ project on behalf of yes. Pedro, we are happy to hear your presentation.
As Elena says, I'm the technical responsible of READ. READ is,
I don't know.
I will give you a general overview about what is the READ. Like other siblings project that already has explained what is manufacturing as a services. They have perfectly explained it. So what is different in READ is we are offering now manufacturing as a service, but for bulky components, for big
together
components.
with us, Dimitris Patharakis.
And why for big components?
Dimitri, can you hear us? Yes.
Many challenges. Some of them is,
Dimitris
as you see in the photo,
technical manager of the
pieces
UniMaas
can be like 4 or 5 meters long.
He's currently a
2
postdoctoral
or 3
fellow
tons.
in Edmond Lab at the
it's very difficult
National
to
Technical
handle.
University of
It's
Athens.
the manual, the process to
let's
align,
continue
to
with
assemble,
UniMaas
to machine
project,
them.
and then I hope
has
that
a lot of
Pedro will
manual
manage to
process,
join the call and
it's
continue
create
with me. So,
hazardous
Dimitri.
working conditions.
Thank you, Eleni.
Also,
can you see my slides?
Since they are big
Yes, in
pieces,
presentation mode, so it's perfect.
The batches are
perfect.
small.
So
it's not a
I'm gonna
repetitive
speak briefly around 10 minutes about
way.
what we are trying to build
we
in
are
the UniMaas
doing very specific
project.
pieces. We
are building a platform for the unified modeling and automated scheduling for manufacturing as a service.
The idea is to help in the process to not to be so demanding the highest precision of the worker that works with the piece.
2 years.
And also, these pieces are very, very expensive.
And the consortium consists of 17
they
partners
we
all
need
around
to
Europe,
be
and we
good
also have one
in
Canadian
our first
partner.
trial.
We have identified
have the opportunity to fail because some of these
first
pieces
stages
can
of the project, some main challenges regarding the manufacturing as a service. So we noticed that there is a paradigm shift regarding how manufacturing resources and processes are offered to different stakeholders. So we have identified that for these processes and resources, they both suffer from disturbances and disruptions, making difficult to build resilient infrastructures, and also there are a lot of variabilities during times. So, for example, the processes offered to a customer may change over time.
Offering a visual monitoring
in
system
the MassAI ecosystem, we
because
move from a
these
single company
pieces
manufacturing
are
towards a network
the
consisting
time to
of different
produce one of these
stakeholders,
pieces maybe
and
is
this
like
comes
a
with
couple of
some
weeks.
key
Some of them.
challenges
So the customers need to have
make
in
reality this
present
vision.
time
So the
all the
first one has
information
to do with
about
the shifting
the
demand
progress
that
of the
propagates
piece.
in the MassAI network. The second one
Later I
has to
will
do with the
explain in
disruptions
detail
of
how we are
productions
dealing with
failing
sharing
to meet the
information
customer
through DPP.
needs. Also,
through
we
data
need to
spaces,
address
because
the increased or
we have
let's say
one
the
of
best
our
utilization
objectives
of
is to
resources
demonstrate
in order
the
to
use of
decrease
grid in
costs, so
real
minimize idle
in real
assets or
industry.
infrastructure.
Who we are
And also that
a group of
manufacturing processes and supply
technology
chains are
providers
becoming
like
increasingly
ModelWorks, like
complex.
Netcompany,
So the
Intrasoft,
vision for
like
the
Solarus,
UniMaas project is
also end
to
users,
cover several
some large
needs. So
end
the
users
first
like
one has to
Komatsu,
do
that is
with
in the
bringing
yellow
together
sector,
stakeholders
but
and
also
SMEs
small SMEs
into a
related
MassAI
with
network through a
drilling
trustworthy, dynamic, and
industry,
decentralized ecosystem.
and also
Also, there is
research
the need to
technological
abstract
center
from
like
the
Sintec,
customers
Fideco,
the
Informatica,
expertise
the
in
University of
order
Darmstadt.
to and provide adaptive
Trying to
modeling and
focus in
enable the
DPP,
overall
I will
servitization
try
of supply
to
chains.
offer a
Also, there
first
is a
glance
need for
about
planning and scheduling
how is the process
algorithms
in REIT.
that build modular and
In
flexible
REIT, we
supply
are
chains that can
thinking
change
in
over time and combine various
manufacturer
stakeholders.
as a service platform. So we have
Also,
like
the final
a
thing
common phase that
has to do
for all
with how to
this type
enable
of
in the modeling part and the
platform
decision
that is
making,
okay. We need to
sustainability,
the manufacturer
resiliency, and the
register
circularity
the
aspects
capacities, the information of the
in
plant,
order to
the
provide
capabilities,
overall
capacities, and production
resilient
cost.
infrastructure.
But
So,
here,
because manufacturing
later
data are the
we
cornerstone
have
for MassAI,
something that is very,
we
very
are
specific of
building,
REIT. That is, okay,
we are also
once
relying
we have
in
all these
manufacturing data spaces.
plant
So we are
information in
building
our
a layer
system,
for interoperable and
customer is going
trustworthy
to request a
servitization
quotation,
across
but
different stakeholders of the MassAI network
since
to
this
enable the
quotation
trust,
maybe is the first
to enable
time
the cross-company
that
data exchange. Also, the
manufacturing
platform
produce this
consists
piece,
of a
the
key
system
component
must
for the
match
unified
between
on-demand
the
modeling
capabilities
of the
and the
resources
order.
and supply
It's not,
chains. We also
one by one.
rely
I mean,
on
it's
intent, which
here
is
the
in
capabilities
the notion of
are
intent, which comes
to
from
produce the pieces.
mainly
So we
from
have the length,
network optimization or
or we
cloud
have the
computing,
capability to produce
where
this type of
customers declare in natural language
length pieces, or
their
this
high-level
to blend
requirements,
this
and
amount
then
of
a
steel.
translation
But
process follows
we
to
have
map these
like
high-level requirements
a
to
strong
specific constraints
dealing
in the
with
modeling problems.
how to
We also
match
build
between
flexible
order
decision-making
and production.
algorithms for
Okay,
to
once
enable the modularity,
also to provide the
reconfigurability
quotation,
of supply chains
since
towards
maybe
circularity
you have not
goals
produced this type
and
of pieces
sustainability
as
goals,
manufacturers,
and the
or you
overall
have
adoption
produced
of
not
cutting-edge
a lot of
digital
times.
technologies for cloud
We are
manufacturing,
offering
for example,
different
digital twins
artificial
or
intelligence tools,
cloud-based
digital
monitoring
twins to
components.
help to
So
provide
we are
quotation.
building our platform across three different
The different
suits, as we call them. The first one
the
has to do with the
different
data management.
manufacturers
The
offer
second one
different quotation to
regards
some
modeling, and the third one
asking for
regards
some
decision
order
making.
request.
So you can see that we
One
have
of them
several
is
components
selected.
in
It
order
can be
to
selected by price, by time, by CO2 emission,
bridge
by
the
quality.
collaboration between these different components and
quotation
enable
can
an
offer
overall
different
pipeline
advantage.
for the automated modeling
once
and production of assets
some
in the 4 pilots
producer
that
has been chosen,
we have in the project. So the
the
first
platform
pilot
REIT
has to do
help
with
to
the aircraft
produce
maintenance.
this
The second one
this
has to
part
do with the
according to
automotive seat
specification.
manufacturing. The third
Always
one has
we
to
are
do with 3D
updating
construction
the platform
printing.
with
And
information.
finally, we
As I
also
said,
have a logistics and
since this
warehouse
process
management
can
use
last
case.
many days, even weeks. So we are
for
always
the data
updating
management
information
part, for the
to the
data
general platform.
management suite, the two
We
main
have
challenges
a
has to do with
very
the data
strong
sovereignty
point in
that allows different
environmental impact.
stakeholders to keep the
The
control
platform is
over the
always
data
tracking,
and
because these
how
pieces,
data are shared across
depending
different
how you produce
stakeholders,
it,
and also
has a
regarding
different
data
environmental impact.
security that
The environmental impact of each pitch
mainly
is quite high.
consists of
Also, we are monitoring the
implementing some
manufacturing
identity
process
management
to
in order to
ensure the
control
quality,
how
to
data
ensure
are shared.
the
So
needs of the
what we are
client.
trying to do is to
And
build a
we,
MassAI
once
network
all
that
this
consists
information,
of
when the
different
piece is
stakeholders,
produced, we
enable the
put
on-demand
the
shareability of data
important
when
information in a
needed,
digital product
following
passport,
some
and
specific
we deliver
permissions
the
for
the
each
piece to the customer,
stakeholder. and the
we
creation
share
also of
the
digital product
digital
passports
product
that enable the
So,
traceability
if we
of
go more
products
in detail
and
in how
also
we deal
the
with
secure
environmental
storage in
impact,
cloud
the
platforms.
idea is we are dealing with
Also regarding the
LCA
interoperability of
models
data, because
that has the
one key
mathematical
challenge
models
has to do with how
to deal
to
with
share the
environmental
data
impact,
in a
and we
secure
use
way,
two
but
types of
the
data,
other challenge has to do
background
with the
data,
interoperability of this data.
because maybe it's the
So
first time that you produce this piece.
we are
So we are
relying
using
on knowledge graphs
information from the
and
past or
specific
information from
ontology
other
that we have
sources,
created for the
trying to
manufacturing as a service model
during
in
the
order to
simulation,
build
trying
knowledge
to
graphs that represent the
offer
capabilities of
a
different
footprint
stakeholders
simulation,
and the overall
but also
infrastructure.
for ground data, real data from the production partners
And we are
when we are
relying in this
producing
ontology to
the
capture
piece.
these
So
capabilities
during
and
the
find interconnections
simulation,
between the
the
different
idea
stakeholders
is
and provide finally
we
a
are
unified
offering
abstraction
different
for the on-demand modeling
configuration that
of
is going to
the
offer
supply chains.
different
I have another slide for that
environmental impact.
in a second.
So the idea is to simulate and
So
forecast
the
the environmental
second
impact
main
before
part has to do with the
implementing.
overall
So we are using
securitization of the
background data.
platform. So here
And
we have
once
a simple
we are
example
producing
on
the
how we
real
are trying
piece,
in UniMaas to
we are
abstract
going
expertise
to
from
monitoring
customers
tool phase,
to
and
provide
we are
seamlessly
recording
the
information
participation in the
from
MassAI
the
network.
system. We are
So for
using
example, we start from
the LCA
a
models
customer
to
order
offer
that defines the
real
final
data
product or asset
about
that needs to be
the environmental
manufactured
impact
by
of
the
the
UniMaas
pieces.
platform.
And we are
And
recording
this
all this
order comes
information in
along with
the
an intent,
digital
which is a
product.
high-level description of the
So
requirements.
it's
And then we need to map
further
this
step to
high-level
explain it is
intent into
okay.
specific
We have the
modeling
quotation
constraints
phase,
or
and during
optimization
monitoring
goals
phase,
in the modeling and
we
decision-making suits.
request
So
data
let's
from
say
the
that
DPP.
a simple
We are
schematic of what we are trying to do
requesting
is that
data
we
from the
start from
sensors.
this order and
Also,
intent.
with
We
this
have a specific
information, we are
chatbot
uploading
that
it to
acts as an
our
interface with the customers.
life cycle
And
environment
then
performance
the
model,
chatbot
and
interacts with the
it is going
corresponding
to
knowledge
offer
graph
information about the impact
in order to produce a
piece
translation of these
related with
requirements
footprint
and
simulation,
extract a
and
specific
we are going
subgraph
to
of the knowledge
use
graph tailored to the
asset
intent
administration
of the
cell. We are
user.
going to
So this
store the
means that
data
we are
in a
enabling
DPP.
from the whole infrastructure that is mapped into
So
specific
what
knowledge
is a
graph.
DPP?
We extract a part of it in
As
order
many of,
to
well, I suppose that all
reduce
of us
also the
know that,
complexity of the
but
problems
what
that
is
we
a
need to
DPP
solve
is
and enable the
structure,
embedding
digital
or
data
matchmaking
that
of this order
it's going to accompany,
into
it's going to
the
every product,
following
not
the
every, but
decision
much,
of the
many of the
modeling and
products that is going to be
decision-making processes.
produced and
So
sold in
UniMaas
the
acts as
European
an
Commission
intermediary
is going
broker
to have
between
a DPP.
the customers and the
The
MassAI
idea is
network
this
in
DPP
order
is
to
going to offer
realize the
the
orders
information through
that
the
come
whole life of the product,
customers. So
from the
regarding the
design,
modeling,
producing and recycle,
we are
and the
trying also to
manufacturing,
incorporate
consumption,
AI
and
predictions to
recycle.
capture
The
the
idea is to
disturbances in the
promote
supply
the
chain
circular
and
economy,
increase the overall
to promote, to
resiliency.
offer information
And
that
in
helps to
the
reduce the
backbone, let's
product,
say, of the
that helps to
platform
repair,
of
and
UniMaas
also
is to
at the
start
end
from the
to
knowledge
helps to
graph and
recycle
create
the
some
product.
models
The idea is also that helps to
consist of
optimize the
just
supply
right
chain, because
information, as
we
we
can
call it.
share
So
some key information
we model
always
the
through
specific
a regulatory
infrastructure,
compliance,
also
and
incorporates
always
the AI
offering
predictions in
relevant
order to
information
build flexible
both
decision-making
for
on top of
consumers
that
and for
and
authorities.
solve some of the basic problems
But
in the
this DPP
manufacturing
is
domain,
quite
such
new.
as
The
matchmaking
law
or the
that
optimization of the
the
overall
ASPR
infrastructure.
law, the
And
Eco Design
again,
for
here we
Sustainable
have a
Product
simple
Regulation,
figure that
it was
on the left side,
adopted
you can see
1
the
year
knowledge
ago in
graph
2024,
for the specific ontology
and
that
the
we have designed
2025
for
was the
a
standardization
specific
about
use
what
case. And we want to
the
transfer
law
from the left side to
talk
the
about
right-hand
the
side
DPP.
of the slide.
And
So
we are
build, for
still
example, a supply
here.
chain network
There is
that
not
consists of different production layers
mandatory DPPs by
offered
now,
by
but
many stakeholders,
in less than
and be
1 year,
able
on
to
1 year, the DPP is going to be mandatory for batteries,
decide, for
and
example, the flows
following
of the
year,
incoming demand,
also
the
2027
production
is going to
rate
be
in each production layer,
adopted like
trying
mandatory
to
by other things like textile,
optimize the
dyes,
overall supply chain
even
and
steel.
make strategic
And this is a process that
reconfigurations
we have
towards
just
high-level
started now,
goals
but
like
is going
circularity and
to
resiliency,
go, as I said,
using also
to
digital
all the products,
twins
many
in the
of the
process.
product that
So
is going to
I
have
think
their own
that's it
DPP.
from me.
It's going to be compulsory. But the law,
Eleni,
what talk about the
Thank you
DP.
very much, Dimitri.
The law says that
yes, I have a question for you. What are the benefits from the analysis you did so far, bringing to decision making in scheduling, and also the resource allocation as well? I don't know
every product
if you can share some information with us about the benefits.
Also need to offer
for
a way
example,
of
based
to
on the
protect
demand
the data,
variability,
and
there are periods of
also
time
says that the documentation should have different layers, maybe
the
some
defined production rates
public information, but
for
also
some infrastructure sites
information for the
results
following
in idle resources.
the following parts of the process
what we
with
are
more
trying
detail.
to do is to minimize, let's say,
And what is most
the
important
active
is
nodes
the technological
in the
neutrality.
infrastructure.
Doesn't impose
And to
any
do this,
specific
we are
technology,
employing
but
also model predictive
the technology that
control in order
any
to
DBP
capture
use
the
should
dynamics
be
over a
interoperable,
time horizon,
should be
and perform
that
optimal,
can
let's
be
say, resource
allow
allocation and
the data
scheduling
portability, because the idea is
to
go
better
with the
utilize
product
the
in the whole life.
resources
So
for its
the
use
idea
case.
is to this data should be portable.
Perfect. Thank you very much,
Also,
Dimitri.
always based on
I see
standard,
that Pedro joined
interoperable,
the call
matching readiness.
now. So as I mentioned
it should be
earlier,
transferable.
Pedro is
So the idea
the
is
project
that,
and technical
all should
coordinator
be
of the
based
READ
on
project.
standards.
And
So,
he will share some
ClearPass is
information
another
with us
European
about the
project
digital
that
product
was like
passport with integrated
maybe it's
CO2
the
consumption
first of
tracking.
the leader of
Perfect.
the
Can you
DBP
see my screen?
in
Yes,
research.
yes.
So we have learned about some of their
Start with the
best
presentation.
practice. So
As Elena
they
says, I'm the
define
technical
some
responsible
of the things that we are using. For instance, they define different clear roles. The economical
I will give you a
responsible of the
general
product,
overview about what
but
is
also
the
the public authorities or
like
the
other
end users
project that
also
already has
provide
explained
how to
what is manufacturing as a services.
the access to the information by
perfectly
role.
explain it.
So what is different should have different access to the data.
Offering
Manufacturing as a service, but for bulky
components,
what type
for
of
big
information, what type of and why data
components, because
format
it
data we should
many
use.
challenges.
And
Some of them
recommend
this on
the
LD
photo
like
by default.
pieces can be like
But in the
4 or
case
5
of the
meters
industrial
long,
sector, like
weight
in
2 or
READ,
3 tons.
so
It's very difficult to handle
as
the manual, the process to
as a way of
align,
complementary
to
industrial model.
machine them.
This
Has a lot of
in
manual
this context,
IDTA,
create
the International
Working
Digital
Association
is defining
also different
since they are big
assets, different ES.
the batches are small.
Meta models.
It's not a
repetitive,
for instance,
we've seen that they are producing
so we are
for the digital
doing very specific
battery
pieces,
passport,
very
also the production part
to
of
produce
footprint.
pieces,
So different
some of them are
quite models
complex.
is going to be produced by EDTA.
The idea is to help in the process to
talk about
not
verify
so demanding the high expertise of the worker that works with the piece.
The
And
information
also,
should be
these pieces are
signature
very expensive.
must be
Trusted.
They are
talk about
we need
blockchain
to be good
to strengthen the trust between the different actors.
We don't
also to
have
verify
the opportunity to fail because
that
some of these
the
pieces
integrity of the
can
information on the
cause,
DP
some
many
hasn't changed since it's going to last many years. To do that, not alteration proof.
The previous project has
All
explained,
things
for MassAI has explained.
we also have like two pillars.
We are
the
proposing.
This is my last slide. So I will try to explain in detail.
Digital twins in the software pillar
we have to improve the
efficiency,
but
also
economic
in the hardware we are offering different
roles,
services,
the
different assets
in our
to
case is,
align
for instance,
Komatsu,
that is
piece
one of
to
our partners
improve
that
the
are
drill,
producing
to
one piece,
improve
the
quality
each of our
the drill.
manufacturers is going to
Also,
have
we are offering a visual
a server,
monitoring
an asset
system,
administration server,
because
this
these
asset
pieces
administration
are
server is going to have different
the time
models,
to produce one of these
different
pieces maybe is
templates
like
for
a
the
couple
type
of weeks
pieces that
some
they
of them.
produce.
So
The
customers need to have
data.
in
It's like
present time
the template
all
of
information about
which
the progress of the piece.
should be stored.
Later I will
maybe
explain in detail
if we are
how
the first
we are
step
dealing
in
with
the process,
sharing information through DPP.
we are going to
through
to
data
start
spaces,
here,
but
We think that we are going to be, as we have in a supply chain, one of our we are going to use like data connector. We are going to access to previous DPP data. Who we are? We are a group of technology providers, like motherboards. We are going to collect data, get company interest from the previous step of the process, but also end users, some large the life cycle for the like Komatsu, that is in the yellow sector, but also small footprint related with vibration data and industry, some and also measures of the technological center, like the different information that the University of Darmstadt. We are going to ask for real data, trying to focus in DPP. I will try to offer an instance first glance about how is the public information read, but also in read we are some models thinking in information that maybe is useful for a maintainer or a recycle later. A common phase that we are all the storing type of platform that is all okay, we need to produce the manufacturing, collect all information, the capacities, the information of the plant, blockchain capabilities, capacities, to ensure and production cost. No one's changed the information. But here to offer this trustnet that later we said that it was important. Something that is very, very specific of we need to publish this data. Once how we are going to publish this data information, we are going to have an API customer is going to request quotation instances and is going to since this quotation maybe is the first time that different DPPs manufacturing produce this we are going to the system must match offer between the capabilities going to and the order to the information and we are going not to provide one a way of accessing the capabilities are what is a way of accessing the data produce data the pieces so we have the length or we have the capability to produce this type of product. So we are going to pieces or this to blend a way of this amount of steel, but in a web page we have like so we need to offer unique dealing with creator. We are going to offer match this plate order this unique number. Okay, once is going to also to provide the quotation one by one with the instance maybe and it's going to be you have not produced this type of pieces as manufacturer but you have produced that are not a lot of times we are offering of course we are going to intelligence tools digital twins one of our end users to provide quotation access to the data he can access the different in two ways one is using different manufacturers barcode for different quotation that is in the product so asking for going to ask for the information and one of them is the role is public data selected by price by access to the API CO2 emission we are going to offer different quotation can offer different advantage identity credentials and through credentials some we are going to offer information to the end user and also by the web page the platform where it has helped to produce actors this passport information this same always we are to have doubting the platform with information as I said since this process can last many days even weeks depending on the role we are always we are going information to the private general platform and we are going to offer information very for this supply chain actor is important to environmental impact the product or the offer is always to know about the quality these pieces so we are going to offer depending how you produce it public has information for the end environmental impact but also we know that we are in a chain it's quite high where we are offering also we are monitoring more detailed information process to ensure the quality to ensure the needs of the client this publishing information and we are offering information one different type of user interface we put to access to the important information in a digital product passport and we deliver the piece to the customer and we
I have
share
a quick question for you regarding the READ platform. I don't know if it is possible to support the integration of the DPP and the CO2 tracking,
we are
and if
dealing with
yes,
LCA
in what
models
ways?
that has the mathematical models to integrate both to deal with the environmental impact and we use two type of data we are going to produce a DPP because maybe it's the first time that you produce this piece. So the DPP is going to have information from the past or information from other sources, from the mails, from the system. We are going to the simulation, depending on the template, but we are going to complete the template, footprint simulation. But also for ground data, real data from the production partners. One of our key elements is the piece. So the CO2 simulation, the life cycle, environmental performance model, offering so the idea is, okay, with this information coming from the sensor, we are going to different offer environmental impact of the LCA. So the idea is to simulate and forecast the environmental impact. Also, we are going to implement the people. So we are using coming from the sensors, and once, but also we are producing the real piece coming from the environmental monitoring tool phase. And we are recording information from the system.
Please don't forget that you can use the Q&A section in case you are having any question. And now it's time to move to the last presentation for today.
And we are
on behalf of
all this
MassAI
information
project,
in
we are happy to have today with us Michele Engel, Matteo Casali, who is the technical project manager of MassAI project, and he's representing the Polytechnic University of Valencia.
Request data from the
thank
DPP.
you, Eleni. I suppose you can hear me and see my screen.
Data from the sensors.
Yes, perfectly.
Perfect.
Also,
okay.
with this information,
well, hello
we
everyone.
are
As
uploading it to our
Eleni and
life
Miguel
cycle
Angel,
environmental
from the
performance
Resistant
model.
Product Management and Engineering from the
It is going to
Universitat
offer
Politécnica of Valencia,
information
Spain,
about the
and
impact
my
of
role
the,
in this project is
of
in the part of the technical
piece
management.
related with
We are
footprint simulation,
I'm working to
and
try
we are going
to see the development of the all of the solutions, the technical,
we are
the
going
communication,
to store the data
implementation,
in
the
DPP.
technology that are interested to use it.
So
Today,
what is a DPP?
Thinking always in the needs from the
As
final users.
suppose that all of us know
with
that,
all of this, I'm going to present a little summary about the things that we are doing in this project. As I said previously, MassAI is the Agile Manufacturing as a Service through AI autonomous agents.
Not every, but
what is the
many of the products that is going to
pillars
be
or the things that
themselves
we want to cover with this project?
Is going to have
previously in other presentations we said that the manufacturing as a service is a topic very interesting. All these projects go online in this way.
From the design,
in the same way, the MassAI project want to transform the manufacturing process in a digital way, enable the demand of the production while reducing the waste and optimizing resources using across the value chain. To do this and provide more interesting technologies, we included some intelligent automation. This intelligent automation is we want to use it. We want to use agents that provide all information about disponible artificial intelligence to facilitate the negotiation between the consumers and the providers that they want to sell or use the machines. In the moment to develop these agents to facilitate this communication, always we need to think in the integration of these tools inside the factories. And I think it's one of the most tricky or interesting part of the project, try to include all these technologies and facilitate the use for the end user. To do this, the structure of the project is divided in, we can say, in three levels. One is the cloud level that provide a marketplace, interactive website to facilitate the communication and the deployment of the machine between the consumers and the providers, and other two different ecosystems, that is one for the consumers and the other one for the providers. With all of this, I want to go more deeper with the MassAI, but MassAI at the end is a system designed to support the manufacturing as a service ecosystem. Here we have two different actors. One is the provider that they offer the machines, and other one is the consumer that want to rent and use these machines. As I said previously, to facilitate this communication, we create this closed mass marketplace. This platform provides a list of manufacturing assets, and the consumers can search the needs, use it,
protect the data, and also
create a
says that
contact
the documentation should
with
have
this
different
provider
layers
to
maybe some
integrate the EA.
public
We
information,
use
but
the
also
agents that I explained
information
previously
for
with
the following
different models to
the following
manage
parts of the
this
process with more
communication and
detail.
facilitate
And what is most important is the technological
the buy
neutrality.
of the final
Doesn't impose
product
any specific
between
technology,
between
but
them.
the technology that
To improve
any DBP use
the information
should
that they
be
needed, the
interoperable,
agents needed to
should
facilitate
be,
this communication, we included
that can
some
be,
different tools.
allow the
One
data
package is
portability, because
more
the idea
tools
is
aligned
to
with the digital twins
go
and the
with the
digital
product during
industrial
the whole
passports.
life. So
Previously,
the idea is
Pedro
to,
explained very well what is
this data should be portable.
passport.
Also,
the MassAI
always
want to provide a
based
tool
on
that
standard,
facilitates the creation of these
interoperable, and
passports
machine readable.
with technologies
So because it should be transferable, so the
and
idea is
other
that
interesting AI
all
models.
should be based
Something
on
similar with the
standards.
digital twins.
So,
We created with a tool
TIRPAS is another European
specific
project that
asset
was like
that
maybe
allows
it's
the
the
possibility
first of
to predict
the leader of the
or
DBP
analyze
in research. So we
the time
have
that you needed
learned
to
about
create
some of
the product,
their
and this information
best practice.
improve
So
the agent
they
and provide this
define
information to the
some of
consumer.
the things that we are
For
using.
facilitate this
For
communication
instance,
or
they
to
define
visualization of this
different
data,
clear
we create
roles,
a
the
set of
economical
tools with the control
responsible of the
panels and
product,
remote
but
monitoring to
also the public
facilitate this
authorities
update
or
about
the
the
end
status of
users.
the final product.
Also provide
Finally,
how to
one of the
regulate
most important, I
the
think,
access
most
to the
important things
information by role.
when we do a communication
Different
between
roles should have
factories
different access
is
to the data.
security. We
Also
integrated
talk about
some
what
tools
type of information, what type
to
of
added
data
a layer of
format data
security
we should
with the
use,
smart contracts, blockchains,
recommend
other
JSON
tools to
LD
facilitate the
like
communication
by
point to
default.
point.
But in the case of the
As you
industrial
can see
sector,
here,
like
we
in
divided
grid,
the solutions in some
also recommend the
packets
asset
and some
administration
slots.
cell
We
as
have
a way
four
of
first solutions, that
complementary
is
industrial
closed mass
model.
marketplace, mass
And
production
in
hub,
this
mass dynamic catalog and
in this
recommendation system.
context,
This is a
IDTA,
tools that works all
the
in a
International
closed level,
Digital Twin
and all the
Association, is
persons in the
defining
future,
different
all the companies can access and
assets,
use it
different
because it will be free
EDS
for all. It's like
with meta models, and some of them, for
the
instance,
land page to
we've seen
start
that
to use
they
the
are
MassAI.
producing
Thanks to this, the
for the
consumer, the
digital
provider can
battery
access,
passport,
check it, and
also
see
the
if they are
production
interesting
carbon footprint. So different
to share the
submodels is
sorry,
going to be
the
produced by
machines or something like
IDTA.
that. Then we added some
Also,
parts
TIRPAS
in a
talk
level,
about
that is the
the
control,
verified credentials to
the control
identity,
panel
the
or the
roles,
agents, because
the
these
information
tools
should be signature
is
that
used for
must
communicate
be
the
trusted.
providers and the
Talk
consumers,
about
the
blockchain
agents, because we
to
included
strengthen the
this
trust between the
easy
different actors,
communication with these
also to
tools.
verify
A set of
information
tools
that
like digital
the
twin,
integrity of the
workplace
information of the DBP
configurator, supply chain simulator, or smart or repair
hasn't
reuse
changed,
recycle.
since
That's
it's going
all
to
solutions
last
that
many
improve
years
the
to offer
experience
not iteration
with the
proof.
use of the agents, and at
So
the same time that provide
all
very
these
interesting
things
information for the companies
follow to how
that can use it
in grid we are
to
proposing. This is
provide
my
better
last
prices,
slide. So I will
better
try
cost about the
to
production,
explain in detail.
or to provide more
Okay,
information to consumer
we have
to, at the end, facilitate the
some
decision to
economic
create a contract with another provider.
roles
Finally,
is
but not
in our
there was
case is,
data
for instance,
integrator, or
Komatsu,
it's
that is
data
one of
storage.
our partners
That's
that are
interesting because
producing one
data
piece.
integrator is a tool
So
to connect with
each of
different
our
kind of
manufacturers
ERPs
is
or
going to
MIS
have
that we use it in
a
all the
server,
factories.
an asset administration
Taking
server.
account is mapping
This
with
asset
all this
administration service
information.
is going to
We
have different models,
mapping all this
different
data with
templates
a
for the
standard
type
like
of pieces that they
is an
produce.
85. That
This
is a
model
standard used
person has data. It's like
for
a
example, by
template
SAP
of
or
how
other
which
biggest
data
companies. And we
should
provided
be
this
stored.
structure inside
Okay,
the each data store.
maybe if we are the
Finally,
first
that I
step
said
in the
before, secure
process,
messages,
we are going
blockchain, a smart contract to
start
provide
here,
the
but
security
we think that
inside
we are
all
going to be
the communication
in a
between
supply
the
chain.
consumer
So
and
we
the
are going to
providers.
use like a data
We can
connector.
see
We are
here
going
more bigger
to access
the
to
picture.
previous
Well,
DBP
for
data,
all the solutions, when we started
of the piece,
to design
but
and
also
develop, always
we are going
we
to collect
started
data
thinking in the point of view of the end user.
But also
I want to
for
say it's not the same
cycle for
the role or the view that they have the engineer or the developer or the data engineer than the other, more in the business level. To do this, we need to do a very high investigation to know what is the final client taking and with this information, try to focus and provide a better solution to facilitate the use at the end, because we want to provide these tools to the companies, and we want to use it at the end.
For a recycle.
Well, all these solutions, all these solutions or the whole platform will be tested are going to test it in 5 different pilots. These pilots work like consumers, and some of them contact with other pilots to facilitate information in the role of the provider. As you can see, the final pilots working in very different
an API that is going to interact with the instances and
products. For example, factories, a metal factory, but Barastasis from Greece is a factory that works with food. We want to provide that this platform that we want to offer at the end with MassAI is for all the companies, because it's not only focused in one kind of material. I think it's very interesting for the future to have this kind of platform. Well, to analyze a little bit, what is the goals of the what is the goals of the MassAI? Well, as I said previously, create this dynamic marketplace to facilitate
we are going to
provide this machine that is not working in some moment, machine as a service that is at the end of the
one by one
project.
the instance, and is going to be
improve this
DBP
communication between
data
the
repository
factory with the agents and the and the models, always thinking in explainable artificial intelligence to facilitate
access to the
this
data.
information.
He can access in two ways. One is using
improve
this barcode that is
the value of the factories,
so
thinking always in the circularity and optimizing the resources we use it.
Public data,
and well,
going to
that's
access
more or less the key benefits that we find with the MassAI. Reduce investment costs, improve sustainability, instance collaboration, leverage the incompatibles, and boost the productivity and
also by a web page.
To finalize, we are now in the first year of the project. We are starting to build some tools, build all the tools, and I put some capture of the two solutions, the data analysis environment and the control panels, because we think that is very visual to the end user. And as you can see, we are in one moment that we are starting to implement these solutions in the pilots to receive some feedback and try to improve it and provide this this user experience that sometimes is very important
we know that we are in a chain
when we're thinking in the development of the solutions.
More detailed
with all of this, thank you for this presentation. Thank you, Elani, for organizing this meeting. I think it was very interesting to see other point of view from the rest of the projects involved in the manufacturing as a service. I'm here to the different questions if there are someone.
Thank you very much, Pedro. Actually, yes, I have a question for you regarding the RIT platform. The question is, how it is possible to support the integration of the DPP and the CO2 tracking and in manufacturing? In what ways?
Okay, well, now in this moment, we started to create this communication with the agents.
We are going to produce
this communication of the agents, take information from the different solutions, and this improve the knowledge about the factory. This communication provide these facilities to know more about
depending on the template,
the cost,
we are going to complete the template. But also,
different things inside the
we are going
factory.
to one of our key
But
elements
we are working on it to try to improve it and provide at the end a better solution.
Emission, the
That's
life cycle,
very interesting
environmental
technology now.
performance model. So the idea is, okay, with this information coming from the sensor, we are going to
thank you all for attending today's online workshop. I added here in the chat the 5 LinkedIn pages from all the system projects. In case you have some questions, you can contact directly those projects on LinkedIn, or you can visit their website. Thank you very much, Pedro. Please note that the recording of this online workshop will be available if you are having any questions. Now it's YouTube. You can visit the project's YouTube account in order to access it. We are happy to have today with us in future more online joint activities will follow. So we are more than happy to have you on the University of Valencia. Thank you very much, and
Yes,
have a nice
thank
day.
you, Eleni.
Bye.
I suppose you can hear me and see my screen.
Yes, perfectly.
Perfect. Okay. Well, hello everyone. As I said previously, Eleni, I'm Miguel Angel. I'm from the Research Center of Product Management and Engineering from the Universitat Politécnica of Valencia, Spain, and my role in this project is in the part of the technical management. I'm working to try to see the development of all of the solutions, taking account the communication, the implementation, the technology that are interested to use it today, thinking always in the needs from the final users. With all of this, I'm going to present a little summary about the things that we are doing in this project. As I said previously, MassAI is the Agile Manufacturing as a Service through AI autonomous agents. But what is the pillars or the things that we want to cover with this project? Previously, in other presentations, we see that the manufacturing as a service is a topic very interesting. All these projects go aligned in this way, and in the same way, the MassAI project want to transform the manufacturing process in a digital way, enable the demand of the production while reducing the waste and optimizing resources using across the value chain. To do this and provide more interesting technologies, we included some intelligent automation. This intelligent automation is we want to use it. We want to use agents that provide all information about explainable artificial intelligence to facilitate the negotiation between the consumers and the providers that they want to sell or using the machines. In the moment to develop these agents to facilitate this communication, always we need to think in the integration of these tools inside the factories. And I think it's one of the most tricky or interesting part of the project. Try to include all these technologies and facilitate the use for the end user. To do this, the structure of the project is divided in, we can say, in three levels. One is the club level that provide a marketplace, an interactive website to facilitate the communication and the rent of the machine between the consumers and the providers, and other two different ecosystems, that is one for the consumers and the other one for the providers. With all of this, I want to go more in deeper with the MassAI, but MassAI at the end is a system designed to support the manufacturing as a service ecosystem. Here we have two different actors. One is the provider that they offer the machines, and other one is the consumer that want to rent and use these machines. As I said previously, to facilitate this communication, we create this cloud mass marketplace. This platform provides a list of manufacturing assets, and the consumers can search the needs, use it, and create a contact with this provider. To integrate the EA, we use the agents, like I explained previously, with different models to manage this communication and facilitate the the buy of the final product between them. To improve the information that they needed, the agents needed to facilitate this communication, we included some different tools. One package is more tools aligned with the digital twins and the digital industrial passports. Previously, Pedro explained very well what is a passport. Well, the MassAI want to provide a tool that facilitates the creation of these passports with technologies and other interesting AI models. Something similar with the digital twins. We created with a tool a specific asset that allow the possibility to predict or analyze the time that you needed to create the product, and this information improve the agent and provide this information to the consumer. For facilitate this communication or to visualization of this data, we create a set of tools with the control panels and remote monitoring to facilitate this update about the status of the final product. Finally, one of the most important, I think, most important things when we do a communication between factories is the security. We integrated some tools to added a layer of security with the smart contracts, blockchains, other tools to facilitate the communication point to point. As you can see here, we divided the solutions in some packets and some slots. We have four first solutions, that is closed mass marketplace, mass collaborative hub, mass dynamic catalog, and recommendation system. This is a tools that works all in a closed level, and all the persons in the future, all the companies can access and use it because it will be free for all. It's like the land page to start to use the MassAI. Thanks to this, the consumer, the provider can access, check it, and see if they are interested to sell the machines or something like that. Then we added some parts in a cloud level, that is the control, the control panel or the agents, because these tools is used for communicate the providers and the consumers. The agents, because we included this easy communication with these tools. A set of tools like digital twin, workplace configurator, supply chain simulator, or smart or repair, reuse, recycle. That's all solutions that improve the experience with the use of the agents, and at the same time that provide very interesting information for the companies that can use it to provide better prices, better cost about the production, or to provide more information to consumer to, at the end, facilitate the decision to create a contract with another provider. Finally, but not the worst, data integrator, or it's data storage. That's interesting because data integrator is a tool to connect with different kind of ERPs or MIS that we use it in all the factories. Taking account is mapping with all this information. We mapping all this data with a standard like ISA 95. That is a standard used in, for example, by SAP or other biggest companies. And we provided this structure inside its data store. Finally, that I said before, secure messages, blockchain, a smart contract to provide the security inside all the communication between the consumer and the providers. Where we can see here more bigger the picture. And well, for all the solutions, when we started to design and develop, always we started thinking in the point of view of the end user. I want to say, it's not the same the role or the view that they have the engineer or the developer or the data engineer than the other more in the business level. No, to do this we do very high investigation to know what is the final client taking and with this information, try to focus and provide a better solution to facilitate the use at the end, because we want to provide these tools to the companies, and we want to use it at the end. Well, all these solutions, all these solutions or the whole platform will be tested are going to test it in 5 different pilots. These pilots work like consumers, and some of them contact with other pilots to facilitate information in the role of the provider. As you can see, the final pilots working in very different products. For example, factories, a metal factory, but Barastasis from Greece is a factory that works with food. We want to provide that this platform that we want to offer at the end with MassAI is for all the companies, because it's not only focused in one kind of material. And I think it's very interesting for the future to have this kind of platform. Well, to finalize a little bit, what is the goals of the what is the goals of the MassAI? Well, as I said previously, create this dynamic marketplace to facilitate provide this machine that is not working in some moment, machine as a service that is at the end of the project. Improve this communication between the factory with the agents and the models, always thinking in explainable artificial intelligence to facilitate this information. Sorry. Improve the value of the factories, thinking always in the circularity and optimize the resources we use it. And well, that's more or less the key benefits that we find with the MassAI. Reduce investment costs, improve sustainability, enhance collaboration, leverage the capabilities, and boost the productivity and flexibility. To finalize, we are now in the first year of the project. We are starting to build some tools. Build all the tools, and I put some capture of the two solutions: the data analytics environment and the control panels, because we think that is very visual to the end user. And as you can see, we are in one moment that we have started to implement these solutions in the pilots to receive some feedback and try to improve it and provide this user experience that sometimes is very important when we're thinking in the development of the solutions. With all of this, thank you for this presentation. Thank you, Elani, for organize this meeting. I think it was very interesting to see other point of view from the rest of the projects involved in the manufacturing as a service. I'm here to the different questions if there are someone.
Thank you, Michelangelo. Actually, yes, I have a question I received for you. The question is, how do the autonomous agents in MassAI facilitate real-time decision-making in manufacturing?
Okay, well, now in this moment, we have started to create this communication with the agents. This communication of the agents take information from the different solutions, and this improve the knowledge bits about the factory. This communication provide these facilities to know more about the cost, different things inside the factory. But we are working on it to try to improve it and provide at the end a better solution. That's a very interesting technology now.
Yes, perfect. Thank you very much. Thank you all for attending today's online workshop. I added here on the chat the 5 LinkedIn pages from all the sister projects. In case you have some questions, you can contact directly those projects on LinkedIn, or you can visit their website. And please note that the recording of this online workshop will be available soon on the YouTube. You can visit the project's YouTube account in order to access it. And please note that in future more online joint activities will follow. So we are more than happy to have you on the future activities as well. Thank you very much and have a nice day. Bye.